got another little project to work on now. It's a ICOM power supply, PS55. Apparently this critter is completely dead in the water. She comes with a 6-pin power plug, 2 of the wires of which controls your AC, which is the blue and the yellow. All you do is jump or two of them and this critter here should power up. Should. Problem is, it don't. It's dead in the water. So we're going to pull her clothes off here now and see what surprises lays beneath the covers of this power supply. Stay tuned. This may get interesting. Maybe. Alright, so we've got the cover, or I should say the top cover, taken off of the ICOM PS55 power supply. And basically, there's not a whole lot to this, to be quite honest with you. You got a control board here. It's not a lot of active components on it. Pretty straightforward. Only active component you really got there, if I can get the camera to aim right, is right here. 2 SB596 transistor. And behind here you have 2 current amplifiers. Let me get me a little screwdriver. You got a current amp back here. You got a current amp back there. You got your bridge rectifier there. You got your fuse right there. You got your power coming in. You got the power going out. And then you got the yellow and your blue. All you gotta do is remove this yellow wire. Well, you know, we want to momentarily power this thing up. Basically, you run the wire, put a clip, alligator clip, whatever, from here, up here, to right there. Jumper wire. And you'll turn this sucker on. There's quite a few modifications out there for these power supplies. One of which is to add a switch to the front panel, so you can use this power supply pretty much on anything. And anything you can. It's easy. Nothing to it. But we'll leave that up to the owner, what they want to do with it. She got a big whopper juicy electrolytic capacitor here, 25 volt, 56,000 UF. 56,000 UF. That's a lot of juice can be stored in that little bugger, let me tell you. Yeah, put your tongue across that one there. So yeah. Anyway, at first glance we can see, actually we shall give you a light bulb with my lovely little cell phone. As soon as I can turn it on, there we go. So basically, someone's been in here playing, got everything all melted. Yeah, that's not good. You got an orange wire there. This insulation's all bugged up on it. The bridge rectifier, the full wave bridge rectifier. Not sure if anybody was mucking around with that or not. Hard to tell. Probably was. Probably weren't. Don't know. The fact that the current amplifiers have been played with leads me to believe that they possibly have been changed, or somebody's been trying to troubleshoot this thing without any luck. Anyways, let's get this jumper wire on and see if we've got any voltages anywhere. Let's see if we can't electrocute myself here tonight. Alright, so what you will see, I have an alligator clip. One side I have soldered down here, and the one to the fuse is a disconnect clip. So basically, if I want to disconnect the AC, all I've got to do is disconnect my alligator clip. Power supply is on powered. Simple as that. And also safer. for me anyway. So let's run some AC through this puppy and see what power we have over here, if anything at all. Anyways, let's see. Well, I guess first we'll do is check the transformer. We'll check the inputs of the transformer, then we'll check the outputs, if I can figure out what wires are here. I'm assuming by the looks of it, should be the blue and the red. Should be the blue and the red. Is your yeah, should be the blue and the red down here at the bottom. Your AC, yeah, I think this, yeah, definitely blue and red. Anyways, let's power up and see what we can get out of here. So just done a few tests on the power supply and transformer. So right now I do have her power, so she is energized. A red LED. Of course, there's the jumper. Again, easy modification to do. I don't like this because there's no real quick way to disconnect this damn thing if she decides to want to volcanically erupt here, other than reach down there and unplug it right quick. By then she'd be well charbroiled, I'm sure. So basically, what's going on here? I checked me red and blue wires down there to the rectifier. And the rectifier has 17 volts being applied to it. 17 volts are being applied to the rectifier. And that's AC. So now I'm going to probe the output of the rectifier, which is this big, heavy-duty, bulky red wire. And I'll let you look at the meter while I try not to electrocute myself here. And there we have it. That's at the output of the rectifier. So we may have a bad rectifier here, quite possibly. So what we're going to do is do some major surgery on the arse end of this here power supply. Basically what I'm going to do is I'm going to disconnect the positive lead, the positive wire from the bridge rectifier, and I'm going to disconnect the negative lead from the rectifier, and then we'll see if the rectifier is producing any voltage by itself. I've seen rectifiers pop before. Believe it or not, it's fairly common to see rectifiers explode internally. But yeah. So let's disengage my my safety alligator clip here and unplug this thing and unsolder that there red wire right there and disconnect the black wire down there and see what we can do. See if the rectifier is putting out any power. Again, we're working on the ICOM PS55. Alright, so as you've seen before, we had no voltage to the rectifier. So we have the output DC removed. So let's see what she's doing now with everything disconnected. Alright, so we're at 19.5, 19.6. So the bridge rectifier is working fine. So it's not the bridge. It's after. It's this wire continued on to the rest of this contraption. Yes. Yes, yes, yes. So power comes in. So basically we're back with the two 3055 output transistors. Yeah, lovely. So that's where we're to now. So we've got a problem back here. Possibly. We may have a short. I'm going to check this wire. Check it against the rest of these connections in the chassis of this power supply. make sure this is not actually shorted. So let's turn the power off and test for shorts here. Alright, so next thing we're going to do, I've got the rectifier output reconnected, but I've got the two 3055s, I got the outputs of those disconnected, which runs back to the inputted board, which gives you the output out. So let's see what's going on, see if we get voltage. If I get voltage back here now, that means we've got a problem with this board. If we still don't have voltage, if the voltage disappears, well, you know, if it's still at 0, then we know we're at the 2 SO or the 3055s back here. So let's continue. Let's turn the power back on and see what we get with two of these buggers disconnected. Again, this is the ICOM PS55. Alright, so we've got the power reconnected. Let's just touch one of these at a time. And you have 23 volts. Why is this back feeding? Got a half-wave bridge right there. Not sure if that's where it's coming from. But anyway, so let's see if we've got voltage down here. We've got nothing there. Let's check the output of this one. We've got nothing there. So we have voltage technically. So we've got voltage back to here. So we have voltage right here. 23. Alright. So our cable is now live at 23 volts. So it is, the board is not regulating. Let's see if I can find a schematic for this power supply. This is getting a bit interesting. Stand by. Let's see if we can print. Anyways, so the two outputs, not the 3055s like I thought they were. They're a different number. Anyways, I have a problem with my printer at the moment, so I won't be bothering with that tonight. But I will try and get it for tomorrow evening and see if we can get a bit further with this here power supply. But anyways, we have 24 volts from the rectifier back to the regulator board, but this is getting so strange. Anyways, again, it's the PS55, and we'll look a bit more into this tomorrow or over the weekend. See what we can't come up with. It's a pretty simple design of a power supply, so I mean there's only so many things that can go wrong on it. You two outputs, you got your rectifier, you got your voltage regulation on this one. It's only done by like 2 transistors. I mean, you know, it can't be that difficult. So it's going like for 10:15 in the evening here now, so I'm getting kind of tired, and I've been pretty busy all day, so I'm gonna call her a day, and tomorrow or over the weekend we'll see what else we can do with this PS55 from ICOM. Anyway guys, I'll bid you do, and I'll catch you later on, and all the best. 7-3, and thanks for watching. And as always, like, comment, and if you haven't already, please subscribe. Yeah. All the best. We gone.